Hi everyone, myself Konda Krishnudu, Assistant Professor of Physics, Department of Science and Humanities, MLR Institute of Technology, Hyderabad. In the previous session, we discussed about Hall effect and its applications. Today, we are going to discuss about photoelectric effect. In this session, I am going to talk about introduction to photoelectric effect, demonstration of photoelectric effect, characteristics of photoelectric emission, particularly Einstein photoelectric equation, finally applications of photoelectric effect and conclusion. So coming to introduction, before going to discuss about photoelectric effect, first of all we should know about the dual nature of radiation. Radiation is said to have dual nature. It is proved already. Radiation has both particle properties as well as wave properties. So particle properties of radiation we can see in some of the experiments like photoelectric effect, Compton effect and theory of blackbody radiation, and the wave properties of radiation we can see in some more concepts like interference, diffraction and polarization. So this is one of the important topic given by the scientist Einstein in the year 1905, which proves particle nature of radiation, or we need to consider particle nature of radiation to talk about photoelectric effect. Now, what is photoelectric effect? Photoelectric effect is the emission of electrons from metal surface when it is illuminated by radiation of suitable frequency or wavelength. So when high energy radiation hits a metal target, in that case electrons comes out from the metal surface. So that is what is called photoelectric effect. And the electrons which are generated are called photoelectrons and the current is called photocurrent. So this is the small diagram through which we can understood the phenomenon of photoelectric effect. A metal surface is taken here. We know in the case of metals plenty of electrons are available here. So this is radiation from the source falling on the metal surface. So radiation consists of so many photons. So when radiation of suitable frequency falls on this metal surface, liberation of electrons takes place. That is what is called photoelectric effect. So this is a small experimental arrangement through which we can demonstrate photoelectric effect. So this is vacuum chamber which is taken, inside of which there is a metal target. So here radiation is falling on this metal target. One photon of light is coming from the radiation and it is falling on the metal surface. When it hits the metal target, electrons will come out. So these electrons will flow in the external circuit and current will flow. So that is how the photoelectric effect is discussed here. Now, what are the characteristics of photoelectric emission? So photoelectric emission has so many characteristics. The first and foremost is photocurrent is directly proportional to the intensity of incident light. Photocurrent is always directly proportional to intensity of incident light. Photocurrent is nothing but number of photoelectrons. The number of photoelectrons that are going to liberate from metal surface is always directly proportional to intensity of incident radiation. That is the first and foremost characteristic of photoelectric emission. The second one, the important word here is threshold frequency. Threshold frequency is denoted by nu naught. So the minimum energy required to liberate electron from the metal surface is called threshold energy, or it is called work function, and the corresponding frequency is called threshold frequency. So finally we can define photo current or threshold frequency as the minimum frequency which is required to liberate electron from the metal surface. The third one is kinetic energy of photoelectrons. Kinetic energy of photoelectrons is always directly proportional to frequency of the incident radiation and it is independent of intensity of incident radiation. Kinetic energy of the liberated electrons. So kinetic energy is always taken as half mv square. So velocity of the electrons which are coming out from the metal surface or kinetic energy of the photoelectrons depends upon the frequency of incident radiation. More is the frequency of incident radiation, then more will be the kinetic energy of the electrons which are liberating from the metal surface. it is independent of intensity of incident radiation. Whatever may be the intensity of incident radiation, it doesn't influence the kinetic energy of the emitted photoelectrons. Next, the most important word here is stopping potential, denoted by capital V naught. So stopping potential is defined as the potential that is required to reject or stop the photoelectrons. The potential, the negative potential required to stop the photoelectrons or to make photocurrent to zero is called stopping potential. Stopping potential is always directly proportional to frequency of incident radiation. Even it also doesn't depends upon the intensity of incident radiation. So that is how photoelectric emission has some important characteristics. All these characteristics are discussed here. Now, Einstein's photoelectric equation. So photoelectric effect was studied extensively for the first time by the scientist Einstein in the year 1905. According to him, the energy of the incident photon on the metal surface is going to be utilized in two ways. Some portion of that energy is going to free the electrons from the atom. So we know atom consists of central hard core called a nucleus, around which electrons revolves around in certain permitted orbits. So these electrons have attractive interaction toward the nucleus of atom. That is, they are bound electrons. So here that energy, some portion of energy, some portion of incident photons energy is going to free the electron from the atom. So that is what is called work function. So the minimum energy required to remove the electron from the metal surface is called work function. The other part of energy is used to give kinetic energy to the photoelectrons. The other part of energy is used to give kinetic energy for the ejected photons. So from these 2 points we can write expression according to Einstein. Einstein photoelectric equation is given by E is equal to W plus half mv square, where E is nothing but energy of the incident radiation, which is taken as h nu, and W is nothing but work function here, work function plus half mv square. So work function is nothing but the amount of energy which is required to free the electron from the atom. So this equation is written here, h nu is equal to W plus half mv square. Now relation between work function and threshold frequency. Here one equation is written, h nu naught is equal to W. So where W is called work function and nu naught is the threshold frequency, that is minimum frequency required to liberate electron from the metal surface. The product of this and the Planck's constant is given by W, which is called work function. So this is the relation between work function and threshold frequency. Work function W equal to h nu naught, where nu naught stands for threshold frequency. Now expression for kinetic energy of photoelectrons. So according to Einstein, electrons are coming from the metal surface when it is irradiated with a radiation of suitable frequency or wavelength. So then what is the kinetic energy of these photoelectrons? So for that we are going to use this Einstein equation, where h nu is energy of the incident radiation and h nu naught is the minimum energy required to liberate electron from the metal surface, and half mv square is the kinetic energy which is given to the photoelectron. Now h nu is nothing but half mv square. Half mv square is equal to h nu minus h nu naught. We can take h as common, h into nu minus nu naught. So we know nu we can written as c by lambda. So using that in this equation we will get this equation, half mv square equal to hc by lambda minus hc by lambda naught, where nu naught is equal to c by lambda naught, where lambda naught is nothing but threshold wavelength. Wavelength corresponds to threshold frequency is called threshold wavelength. h nu by lambda minus h nu by lambda naught, that is h into c by lambda minus c by lambda naught. So this is the expression what is called kinetic energy of photoelectrons. Half mv square equal to h into c by lambda minus c by lambda naught. Now, expression for stopping potential. So we know EV naught is also nothing but kinetic energy. So kinetic energy half mv square is also written in terms of stopping potential as E into V naught, that equal to h nu minus h nu naught, that is h into nu minus nu naught. And from this expression we can write expression for stopping potential. V naught equal to h nu by E minus h nu naught by E, h by E into V minus nu minus nu naught. So that is stopping potential equal to h by E into nu minus nu naught. So that is the expression for stopping potential. Now, what are the applications of photoelectric effect? Photoelectric effect has so many applications in various fields. So the two important applications are highlighted here. One of the most important application of photoelectric effect is that it is used in photoelectrochemical cells. Photoelectrochemical cells. So photoelectrochemical cells are the materials which are going to utilize this effect, what is called photoelectric effect, to convert light energy into chemical energy. In photoelectrochemical cells, photo or light energy is going to convert into chemical energy. So actually photoelectrochemical cells consist of semiconductors. When photons of light falls on that semiconductor, it absorbs those photons or it absorbs light, and as a result of that, electron hole pair generation takes place. These whole electron pairs which are generated will participate in the electrochemical reactions. So these electrochemical cells have numerous applications, like they are used in water splitting, fuel generation and environmental remediation. That is about the first and foremost application of photoelectric effect, where they are used in photoelectrochemical cells. The second important application is that they are used in converting solar energy. You know, solar cells are the materials which are able to convert sunlight into electrical energy. So similarly here, photovoltaic cells or solar cell also called photovoltaic cells. These photovoltaic cells absorbs photons from sunlight, and so that flow of electrons takes place, which is harnessed in various applications including power homes, buildings and even entire cities. That is, photoelectric effect is used in converting light energy into electrical energy. So that is how photoelectric effect is going to be utilized in day-to-day activities. So now the conclusion. So in this session particularly we discussed about what is photoelectric effect. Using a picture we discussed it, and then a small demonstration, experimental arrangement in order to understand photoelectric effect. After that, characteristics of photoelectric effect we discussed, and then Einstein photoelectric equation we analyzed, who studied about this photoelectric effect in 1905, and then finally applications of photoelectric effect. So in the next session we are going to discuss about one more important particle phenomena of radiation, that is black body radiation. Thank you.